Today, the 16th of September 2023, Saturday, the first day of Jewish New Year. Yesterday, we celebrated our Jewish 5,784 year. And Saturday, I begin my presentation lecture about corrosion risk and management and process safety in the chemical engineering processes. You may ask me, what is corrosion? Why is corrosion connected to catalysis? Catalysis, this is my specialty. Yes, I studied the first and the second. My degree in Moscow University, yes, catalysis and many catalytic processes. I did not think at that time, many years ago, about corrosion processes. But then working in chemical industry, I saw many examples and many processes when corrosion influences not only catalytic, but process safety mainly. This is my town city where I live, not exactly in Haifa, but I work in Haifa and Technion. This is my email and my website. I have never been to Valencia. This is Rovi, this is my wife Olga, grows in our garden. Now we begin all times with definitions. Definition is very important for our philosophical approach to any subject, any item, any topic. What is corrosion? Corrosion is an interaction between material and the environment, and which result this interaction in deterioration, degradation of both material and the environment. We have about 40,000 different alloys, 85 metals, but environment maybe 1, 2, 3 phase, I think infinite number of media. And this interaction between material, mostly metal or alloy, will result in corrosion in abiotic environment. This means in soil, water, and air, and as a result will be environmental pollution. But we are interested in process environment, in chemical industry. But there is also biotic environment when corrosion influences in human, fauna, flora, and this interaction may result in deaths, injuries, diseases, disability. And what is important that microorganisms, both in biotic and abiotic environment, may influence also in the appearance and occurring of corrosion. Thus, corrosion impact may influence process safety, but we didn't give definition to process safety. What is process safety? Corrosion. All pictures, as you see my pictures, my photos. Corrosion may result in fire, may result in release of dangerous chemicals, toxic, mainly chemicals, and explosions. These three phenomena are very important for process safety. Thus, process safety is a discipline that focuses on the prevention of fires, explosions, and accidental harmful substances and energy releases at chemical process facilities. Now, when we gave the definitions to main points, our phenomena, corrosion and process safety, we can continue talk about process safety goal is avoidance and control of reaction heats, flammability, explosiveness, toxicity, corrosiveness. This is subject that I deal with this process, and chemical interaction. As you see, catalytic process relate to all these phenomena. And during the last 20 years, we deal with corrosion management. I understand that not all people, not all professionals deal and know what it is. Corrosion management are planning actions of selection, design, corrosion mitigation, prevention, monitoring, inspection, and prediction. And to follow process safety, suitable materials, design, mitigation, measures, and corrosion monitoring methods must be used. Our highlights in my presentation, the first presentation, last day conference, but this morning. The first topic will be what is corrosion risk and the link to process safety. The second point, corrosion management for improving process safety. The third point will be safe design and management strategy from a corrosion point of view. You see, we deal with corrosion and process safety. Large failures because of corrosion once a week occur at chemical enterprises. I worked for oil refineries and petrochemical industry during 30 years. And I can say, this is my research, my results, that at oil refineries and petrochemical plants, these corrosion events occur every 2-3 days. This means that during the year, about 140 corrosion events. 30% of corrosion cases are not reported and registered at all. Usually specialists, professionals in process safety do not know much about the subject of corrosion. Accordingly, corrosionists do not specialize in process safety. I invite you to our journey to the world of corrosion and process safety. Why is it important to learn corrosion? I teach corrosion courses in different universities in Haifa and Technion and in different universities over the world. How did I teach up to 2000 year? The first important point, economics, that corrosion influences economics. Then the second, safety. Then environmental damage, reliability of different instruments, devices, and heat exchangers, reactors, and so on. And the last, preservation of metal sources. Because instead corrosion of metals, alloys, we should extract from the earth ores different metals as molybdenum, iron, chromium, nickel, copper, zinc, and so on. But after 2000 year, more than 20 years ago, 23 years ago, I saw that safety is the first and important. Now I say that to learn corrosion, the first point is safety, then economics, environmental damage, reliability, preservation of metal sources, and safety now is valued over production, but corrosion, unfortunately, is not. Corrosion impact influences process safety. And I would like to see my picture, my vision to corrosion management, that corrosion management consists of anti-corrosion measures, corrosion monitoring, knowledge transfer, and education. You see, I emphasized by red lines, knowledge transfer and education, study of each accident, communication, publication of minutes, management of change, maintenance, regular inspection, enforceability, and human factor in corrosion management. In corrosion accidents, corrosion events occupies about 65 up to 90%. This means that we shall emphasize on our education and knowledge transfer. Documentation and standards used also are included in corrosion management. Thus, all these 11 activities are introduced and occupy corrosion management. Thus, we see this corrosion subject is very interesting for our chemical industry and also for catalytic processes. Corrosion management are planning actions of selection, design, corrosion mitigation, prevention, monitoring, inspection, and prediction. And all these points, all these phenomena events should be carried out During design stage, this is very important. During design stage, we can select, we can design, we can plan corrosion mitigation measures, we can prevent, to monitor, and so on. Thus, corrosion professional specialist as a person in the specific process chemistries, degradation mechanisms, material selection, corrosion control and monitoring, and prediction. And I say during all my career that corrosion and materials engineer should join any projects in chemical industry, especially in catalytic processes. Now I would like to show you 3 corrosion events. The first event, failure of coating, as you see, during 2 years at oil refinery. Pipeline with hot water, 90 degrees centigrade in the atmosphere of the oil refinery, as you see, coating failed. These heat releases, and it is important that people, staff, the workers and operators cannot go around this area. The second event, corrosion event, you see severe corrosion of pipeline transportation of gas to the furnace after 4 years of exploitation, use, application. And this corrosion occurs because of hydrogen sulfide releases, and explosion occurred. The third event, as you see, this was hydrogen embrittlement of carbon steel, and medium was hydrogen, gas is hydrogen at 2080 degrees centigrade with peaks to 380 degrees and 46 bar. After 16 years, there's hydrogen embrittlement occurred with explosion and big fire at oil refinery. As you see, after 2 years, 4 years, and 16 years. Now, I would like to emphasize that this is my division, that we can approach or assess that extremely very high risk after 1 year before Meled and Laura, 1 year of exploitation, very high risk between 1 and 3 years of service, high risk between 3 and 5 years, and medium risk between 6 and 10 years, and low risk after more than 10 years. As you see, the first event was, yes, very high risk and low risk here. And thus, all corrosion phenomena relate to process safety, but in different manner. What don't we see in this application, this accession? We don't see consequences. The consequences we should understand, and we should take into consideration. The consequences here is very low. This is not so low, but here consequences after explosion and fire, yes, are very, very big. Thus, we should approach the corrosion as a hazard. What is a hazard? A hazard is a substance, object, or situation with the potential for an accident or damage. Thus, corrosion is one of the biggest hazards because it's related to substances, objects, and situations leading to interaction between them and deterioration of both. I emphasize deterioration of both because usually you may read in different textbooks, corrosion results in deterioration of metal, metallic construction, device. No, both, and environment also. Now, corrosion risk management, this is identifying, analysis, evaluation, and elimination of corrosion hazards. What should we do? Manage corrosion risk. Risk analysis came from the nuclear and chemical industries in 60s, 70s years of the 20th century. It was standardized and found wide application in corrosion management in 90s of 20th century and now during the last 20 years. We can say about RBI, risk-based inspection. Risk-based inspection is very important today, yes, because it takes into consideration 2 for two events. First, the probability of failure for individual equipment by examining the potential damage mechanisms, and we know, yes, we can foresee, we can expect in any equipment, chemical industry, yes, what corrosion, what type of corrosion can occur. And the second, consequences of failure, how much it would cost if particular equipment breaks down. Thus, these two factors categorized in three groups: health and safety impacts, environmental impacts, business impacts. Thus, risk is the multiplication of probability on the consequences. It's not easy to calculate, but too big, too large documents that were developed by American Petroleum Institute, API, and they began develop these documents in 1993. The API recommended practice 580 risk-based inspection, where you may read about definitions and concepts on 94 pages, focused on loss of containment of pressurized equipment due to material deterioration. These risks are managed through inspection. And the second one, recommended practice API 581, risk-based inspection technology. This is implementing methodology on 652 pages. 652 pages. Yes, I laugh because this is who can read. Yes, but in any case, people work with this document. This standard provides quantitative procedures to establish an inspection program using risk-based methods, means risk as multiplication of probability of consequence for pressure vessels, piping, tankages, pressure relief devices, heat exchanger tube bundles. Shortly, all devices at our chemical industry. How can we determine corrosion risk? First, we should study and analyze corrosion cases and situation. We can predict this. Thus, after this, we can plan for corrosion control actions and then create a monitoring. Thus, you see all these events, all these phenomena, all these activities are based on our corrosion education. Without corrosion education, we cannot use all these approaches. And the human factor plays an important role in control and prevention of corrosion phenomena, and both in industrial process safety. As I understand too, and I say several times during my presentation that human factor is important. Thus, corrosion educated is the first topic that we should do, we should apply. Three causes of accidents. I can suggest you that what are the three causes of accident? Because I didn't know, I didn't think, I did not see. Once again, education culture is important. Yes, and teaching. Thus, I would like to show you environments in the chemical industry. This is very wide environments from chemicals and different compositions of solids, liquids, gases, 1, 2, 3 phases with different pH from alkali to acidic, natural gases, and by red, I emphasize by red color, all these impurities that influence corrosion. Then crude oil also with impurities of water, hydrogen sulfide, salts, microorganisms, petroleum products, fuels, biofuels, then cooling water and aqueous solutions at any chemical enterprise, processed gases with CO2, hydrogen sulfide, ammonia, oxygen, and steam. organic solvents, solutions, and reagents, and of course, atmosphere, soil, and concrete that we use at every chemical enterprise. Temperature may be from minus 200 degrees centigrade up to 1,400 degrees, and pressure from vacuum to 1,000 bar. How can we predict corrosion risk? Once again, when we see the SDS, previously was MSDS, safety data sheets, for every hazardous substances, we may read about flammable, explosive, oxidizing, corrosive, and gases under pressure. What does this mean, corrosive? Yes, I can say that it is not defined, because corrosive, this is a relative definition. For example, ammonia. Yes, you may read in SDS, corrosive. No, for iron, it is protective. It is corrosion for copper, very aggressive. That's corrosion connected to philosophy. And how can we assess corrosion? And using corrosion modeling today is very important to deal with corrosion modeling. The purpose of identification, the corrosion hazards, by defining the corrosion type, mechanism, and expected corrosion rate without mitigation methods. I stress without. As we see, corrosion may result and may be as general in acidic and alkaline environment, and may be localized, about 15 types. That this localized corrosion can result in pits and cracks, and pits may be as a result of CO2, hydrogen sulfide, chlorides, oxygen deposits. Microbiologically influenced corrosion may be as a result of galvanic, crevice, erosion, cavitation. Cracks may be as a result of intergranular, hydrogen attack, alloying, threading, stress, corrosion, cracking. What can we say about passive films or passivity that we observe on the stainless steel, for example, stainless steel 316, yes, and passivity in the metastable state. This is energy system, is direction of the reaction. 1 and 3 stable condition, but usually we deal with metastable condition. Any change in concentration, temperature, flow rate, yes, may result in moving from metastable to corrosion. Thus, we see these corrosion points or T-points, T-spots on the passive films on stainless steel surface. How can we build or create these models? And what can we say about specific corrosion phenomena in chemical industry? Dew point corrosion and corrosion under thermal insulation. This is very complicated, yes, and it is very, it's not easy to describe with such models. What about fouling? Yes, and all this also result in corrosion. The next step in corrosion assessment is to define corrosion mitigation strategy and foresee corrosion rate of protected equipment. Thus, you see that predict corrosion to create corrosive models is not easy for each process. And our aim, yes, our aim is to predict corrosion in chemical industry. Sorry, what it is? Okay. How to predict and prevent or decrease failures? First, corrosion management culture we should use. Then activities. Safety always starts with correct engineering and anti-corrosion design. Forcing managers to establish penalties and incentives. It is very important for us to force managers, please put attention, and legislation in the field of corrosion management on the governmental level, on the federal level in each country, searching how chaotic corrosion processes result in failure. to create models similar to weather models, and to create models similar to weather models using big data. What is weather? I compare prediction of weather behavior, behavior with corrosion behavior of metal in environment. Weather is constantly changing state of the atmosphere, and corrosion is also constantly changing state of a metal environment system. Thus, and I deal with physicists and people who predict weather. We can predict only during several days. Thus, we can predict corrosion now. Yes, also for short period, not for long period. Degree of uncertainty will remain even when we create good corrosion models. Not fighting. Yes, I'd like to emphasize also that many people who deal with do not deal with corrosion, that we fight, we combat, we battle corrosion. No, we should not fight. We should not combat and battle corrosion. We can only control corrosion. Corrosion is a process according to the second law of thermodynamics. Second law of thermodynamics said that entropy increases all the time. We cannot prevent the second law. Thus, we can only control, not fight, not combat. I'd like to show you our Mediterranean Sea. I'm here in Israel, yes. We have only 2 oil refineries, but you may see all our basins, Mediterranean basins. We have 76 oil refineries, only in Spain 9. You see, around these basins. And Mediterranean oil and gas map, you may see in Spain, Italy, Greece, Israel, Turkey here, Egypt, Tunis, and Libya. Thus, we can say this area, Mediterranean area, is very dangerous from the process safety and corrosion, because corrosion influences process safety, and we should put attention and teach corrosion process safety professionals to corrosion phenomena. This situation demonstrates the importance of process safety and corrosion risk management cultures, including the need to establish the process safety as a core value, provide strong leadership, and establish and enforce high standards of performance. Thus, risk-based process safety management and corrosion risk management include best practices, process safety and corrosion training, incident investigations, process hazard analysis, including corrosion, and process safety and corrosion risk management audits. People do not take into consideration, do not carry out these audits. I know 740 oil refineries over the world, only in Europe, about 200 oil refineries, yes, and not oil refineries, for example, carry out these audits. Who runs today corrosion? Chemists and electrochemists, metallurgists and mechanical engineer, chemical, petroleum, biotechnology, environment engineer, energy engineer, electrical engineer, microbiologists, materials engineers. These corrosion subject discipline is interdisciplinary studies we should attain. And process safety engineer does not learn corrosion at all. Education is critical. I say this all the time. And education and knowledge transfer. About 75% of all corrosion failures happen because of insufficient information, communication, interaction, and knowledge. And what is important, we should extract tacit knowledge. We have two types of knowledge. This is general knowledge that you may find in different libraries, in books, in magazines and journals, but we have tacit knowledge. This is only in the heads of our professionals, and we should extract them. We do not do this. Give pedagogical skills to scientists and engineers to be a teacher. When young people, engineers and scientists begin teach, there's not every scientist engineer can teach. We should give them to teach how to teach pedagogical skills and improve corrosion education among all categories of workforce, including management. Give a man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime. This is words of Maimonides, Rambam, a Jewish philosopher who lived in Spain 1,000 years ago. This is monument in Cordoba. I was there. And now our strategy, creation of blocks of textbooks and curricula for categories of workforce in different industries. First, for educators and teachers, then for students at schools, colleges, and universities. Third, for young engineers and scientists, then for experienced practical engineers and scientists, and of course, for managers of different levels. Please take into consideration, emphasize, for managers think that they know all subject. No, we should teach them. And corrosion basics should be obligatory. Collaboration is critical. Thus, this is my point that process safety management plus corrosion management is very important in collaboration and critical for safety and corrosion that should be concerned to everyone, for employer and employee and contractor. Thus, 3C, competence, control, and communication, and heading to zero emission and environment impact. And our goal, safe and healthy in the chemical industry. And prevention is my logo, is better and cheaper than a cure. Then I can recommend my first book, Corrosion for Everybody, the second book, Corrosion in System for Storage and Transportation of Petroleum Products and Biofuel, the third book, Corrosion Problems and Solutions, in order refining a petrochemical industry that came into life by Springer. And my recent book, the first book in Hebrew, I wrote in Hebrew, Corrosion, Control and Monitoring in Industry, then 750 pages. Maybe anybody wants to translate into Spanish or English. Wonderful. Thus, education takes a primary role. And I may say about andragogy and pedagogy. You listened, you heard and know about pedagogy, how to teach children and young generation, but also we should teach adults andragogy. This is how to teach adults a generation. Corrosion is more than a job. It is a passion. And I deal with corrosion more than 45 years. And now this is my last slide. What will be shortage in the near future? Energy? No. Fuel? No. Water? No. Food? No. Skilled, knowledgeable specialists, professionals, and corrosionists and process safety engineers among them. Therefore, I trust in Rust. I hope I introduced you to the third day of our conference, Interest Conference, and created your mood by brilliant music by Dmitry Dmitrievich Shostakovich. He lived in very difficult time under Stalin regimes and pressure, but in spite of this, the difficult times, he created optimistic, major music. This I also believe, yes, that corrosion is not bad, nasty phenomenon. We can deal and we can control corrosion to improve process safety in chemical industry. Thank you for your Sarita, Delia, where are you? I finished my presentation. Are there any questions?